In this video, we'll talk about a really cool feature where you take a layer 3 switch port and instead of it acting like a LAN switch port, it acts like a router port. In this video, we'll talk about where you might want to use that and how to make it work. Let's do it. For this topic, you'll find the equivalent content in the CCNA Cert Guides, Volume 1, Part 5, Chapter 18. That chapter has 4 major sections, and I've made videos for all of those. For this third major section in the chapter, I've split the content into 2 videos here at the channel. The first of those is this video that focuses on routed ports as an end to itself. The next video in sequence will focus on port channels which use the routed port concept and configuration. So here in this video, what are we going to do? I'm going to review that earlier topic from the chapter, SVIs, because it's good to contrast that then with routed ports, which I'll introduce the concepts in the second section of this video, and then the implementation details, how to configure and verify it there in the third section of the video. Then stick around to the end. As usual, we'll talk about where to go from here after you finish the video, including review activities here at the channel, as well as in the book. All right, let's get into it. Do you want to do the review? Well, if you know a bit about SVIs and think you're a little fuzzy, stick around and watch this section. If you don't need any help, you can skip to the next section. If you're thinking, hey, I really don't know anything about SVIs, watch the full SVI video. It's linked up above my head. It's also linked in the description so you can get a deeper look. So 3 options here. But if you just want a quick review, let's do that now. So imagine a design like this, and you've got 2 layer 3 switches up here, and they're going to provide routing services for the subnets that exist down here. So down below, you've got traditional switching services, links between switches that are trunks, links to endpoints that are access ports. They're assigned to individual VLANs. So then to support all those VLANs, you've got VLAN trunking enabled in here. So what we'll do is turn on layer 3 switching, that is routing services in each of these 2 layer 3 switches. Next up, let's expand to a concept view of those 2 layer 3 switches here. So think of each of them as having a layer 2 switch component and a layer 3 routing component there. And even the configuration, it's pretty obvious which part is which once you get into the config. So what do we have to do here to make this work? Well, again, looking at one layer 3 switch in concept with its layer 2 part and layer 3 part. The layer 3 part, we're going to create layer 3 SVIs, switched virtual interfaces, with the interface VLAN command. So if you think of these as VLAN interfaces instead of SVIs, that's what we're talking about here. You create those, and you create one for every VLAN whose subnet you want to support. So for every VLAN, there's a subnet. For each of those, you create a matching interface VLAN whatever command with the matching VLAN number. So we'd have VLAN 201 and VLAN 202. So up here, we'd create interface VLAN 201 and interface VLAN 202. All right. So just thinking about the task, the big picture things from a design perspective, what VLANs are there? So you know what VLAN interfaces to create. You got to think about what layer 2 connections you need between the layer 2 function and those devices, like, configure VLAN trunks, configure the VLANs, configure access ports. And then for the layer 3 part up here, you've got to, quote, enable IP routing. For each SVI, create the interface, configure an IP address on the interface. And then you're probably going to configure a routing protocol so you can learn routes from other routers and tell them about your routes. So we'll wrap up the review just going over the configuration. So concept-wise, think of the 2 subnets with a couple of PCs in each subnet. They sit in some VLANs somewhere out there in the network. And we're focusing on the routing function in multi-layer switch D1 for now, and ignoring the layer 2 functions. So how do we get those interfaces configured and get things going? Well, the first step is to, quote, enable IP routing, and you just configure the global command IP routing. That tells the device you can route IP packets. It also says you can use more than one VLAN interface actively at the same time, which is very handy here. Then in this case, we've only got 2 VLANs, so you create 2 interface VLAN commands. The numbers have to match. We're using VLANs 201 and 202 in this example, so you create those matching interface VLAN commands. And in each case, you assign the layer 3 switch an IP address in those respective subnets. Notice the IP addressing scheme 10.1.10, 10.1.10, 10.1.10 in VLAN 201, 10.1.11 for the addresses there in the right-hand subnet. And there's your configuration so that these hosts can then point to the multi-layer switch's IP addresses for their default gateway and route traffic through the multi-layer switch. The whole reason I wanted to talk to you about SVIs in this video about routed ports was to compare and contrast it with switched ports. So down here at the bottom, all those ports on these distribution switches to the access switches are, quote, switched ports. That is, they're ports on switches that act just like we've been talking about since the beginning of the course. And we didn't even have a reason to call them switched ports. It's just how we described how LAN switching worked. So if I put a big blob over it and say these are switched ports in that you configure VLANs and trunks and LAN switching happens, what does that mean? Frames come in, the switch learns the source MAC address, it forwards based on the destination MAC address using the MAC address table, all that. So all these S's in the diagram that I've hidden now, but now showing them, all these S's mean these are switched ports. They act just like LAN switching that we've been describing all along here. Up here though at the top, this link from D2 to R2 and D1 to R1, well, the router wants to route. Its interfaces do routing. That is, they forward packets. When they receive packets, they try to route them. They match the routing table. They don't learn source MAC addresses. When they receive an Ethernet frame, they de-encapsulate the IP packet. All right, those kind of things. That's routing. So what we can do is we can configure and change the operational approach of these top interfaces to be, quote, routed ports. Those are ports on multi-layer switches that behave like router ports. So they're not called router ports, they're called routed ports, but they're routed ports. So you can think of this now as a point-to-point link between two routers, and they'll have IP addresses on both ends. You'll configure, get this, you'll configure an IP address on the physical interface here on the multi-layer switch. You'll put one over here as well, and routing will happen there over those links. In fact, it's not all that uncommon to put a link between the two multi-layer switches and configure those as routed ports. So now you've got another point-to-point link between those two switches. Again, routed ports. Interesting, huh? So let's compare those ideas here for a few moments. Routed ports and switched ports. So in routed ports, you've told the switch, don't do switching, do routing. So I'm going to forward receive data by routing it versus switch ports, forward by switching. So to expand upon that a little bit, we route received IP packets on routed ports. We switch received Ethernet frames on switch ports. So one aspect of that on routers is to de-encapsulate the packet from the received frame and re-encapsulate it before sending. Whereas switch ports, they don't have to do any of this de-encapsulation and re-encapsulation stuff. Routed ports don't perform any MAC learning, whereas, of course, switch ports do. Then the last two items, more about configuration. If you get into interface config mode on a routed port, it's going to need an IP address command, all right? Just like any other router port would on a router. Whereas a switched port, if you tried the IP address command, it's going to reject the command. Conversely, if you get into interface mode on a routed port and try to configure VLAN or trunking commands like switch port mode trunk, that's rejected because layer 2 commands don't make any sense on a routed port. Whereas, of course, on a switch port, you would configure VLANs and, native VLAN and switch port mode trunk commands to set up trunking and the like on a switched port. So think of this as changing a port to act just like the ports that you've come to know on routers versus the traditional operation of acting like a LAN switch port. All right, so where do we use these things? Well, from the layer 3 switch down toward the end user, that's where we use SVIs and switched ports on the physical ports. That is, let it default to act like it always has. But up at the top, when you've got all these point-to-point connections between two layer 3 switches or between a layer 3 switch and a router, and you want to route between those devices, you can actually configure it with SVIs, but it's better if you just change those ports to all be routed ports. Simplifies the configuration. You get some other advantages as well. It's better to use layer 3 routed ports. All right, last thing on the concept of routed ports. The current blueprint when I made this video was version 1.1 for the CCNA 200-301 exam. It does not mention routed ports, but what it does do, it has one exam topic that mentions layer 3 switches and another that mentions layer 3 ether channel, which is the next video. And layer 3 ether channel requires you to understand routed ports. So that's why we cover routed ports. Today's video is sponsored by me. That's right. So if you want to give something back to the channel to help it grow, click subscribe, click like on every video, or use this QR code or link when you do want to buy something. You don't pay anything more, and I'll make a few dollars back from those booksellers. All right, let's get back into it. We'll use this familiar topology for the example configuration. Down at the bottom, we'll have switch ports and SVIs, which we'll ignore for the rest of the discussion. We'll focus instead on these routed ports up here at the top. So taking a closer look at that, I've picked some interface IDs to use for the examples. I've also picked 3 subnets for our 3 point-to-point links and picked specific IP addresses in those subnets to use for the configuration. All right, what do we configure? Well, here's our config checklist for routed ports. You make it a routed port with this command, no switch port, which kind of begs a question when you first see that is, well, if it's a no switch port, is there a switch port command? So to make a port on a switch act like a switch port, the command is switch port. The alternative is to be a routed port. So no switch port is the command to make the port be a routed port. The default is switch port, and that's why switch ports act like switch ports by default. Then no shutdown administratively enables the port. That's just in case somebody had shut it down earlier. And then you configure the IP address with the address and mask in dotted decimal format. You'll probably configure routing protocol configuration. We just haven't gotten there in the class yet, so I won't really go over that kind of config. So here between switches D1 and D2, here's a reminder of the interface IDs and IP addresses I chose, and there's the config. You get into interface mode for the physical interface. Use no switch port to say be a routed port. Enable the port just in case. Give it the IP address with this command. I picked a mask that's the equivalent of /30, that is 255.255.252, which gives us a subnet with 2 addresses, the .5 address that we configure over on D1 and the .6 address that we configure over there on D2. D2's config is the same other than having a different IP address. Now you can ping each other on the opposite ends of the link, and that should work. Additionally, outside the scope of this video is OSPF config, which may well look like that. It may be different, but I will leave that as an exercise for you if you want to circle back here once you've learned something about OSPF. There is one other variation where you've got a switch connected to a router. Now, router ports, there are ports that act like router ports, and that's all they can ever do. They can't be changed. There are even router models with some switch ports in them that can only ever be switch ports. So there's no need on a router for a command that says be a router port or be a switch port, all right? So the config is the same basically down on the routed port on the switch and on the router, except there's no need for a no switch port command. There's no concept of saying be a router port. It's just not needed, so I show it there with the big line through it. So let's just say you configured just like that. How do you look at it? How do you verify things are working? Well, when you do that on switch D1 and you do a show interfaces command, it's very familiar, right? And you look at the output, say on that link on D1 that's connected over to D2, one telling thing that's easy to miss is you'll see the IP address listed along with the mask. Now, when you do that on a switched port, you don't see an IP address because you can't even configure an IP address there. So if you do on a switch, a show interfaces and see an IP address, that's a clue that it's a routed port. Additionally, show interfaces status. Remember that nice handy command with 1 line per interface? Well, on a routed port, under the VLAN column, well, it's a routed port. There's no concept of a VLAN on the routed port. So what does iOS tell you? Routed. It just tells you it's a routed port. Whereas a switched port that does have awareness of VLANs and whether it's an access or a trunk port, on the trunk ports, it's going to do like it's always done and say trunk Or on access ports, it's going to list the access VLAN out there in the VLAN column. So that's a difference you can watch for and an easy way to find those routed ports. Additionally, remember the show interfaces whatever switch port command for layer 2 switches? That's the command that shows all the detail about layer 2 parameters, like what's the access VLAN, what's the native VLAN, what's the administrative trunking mode, what's the operational trunking mode. Lots of output about layer 2 things. Well, once you make a port a routed port, those things don't apply. So the only output, it's 2 lines of output instead of the usual 20 or so. It gives you the interface ID again. It says switch port is disabled. In other words, no switch port has been configured. All right, last thing that can be interesting then, the first time you've looked at this, is to look at the routing table, right? So if you do a show IP route and focus on those connected routes, on D1, it's got 2 routed interfaces via this config, and we're going to see connected routes for 2 interfaces that are routed ports. Gigabit 101 that's connected up to router R1, gigabit 102 that's connected to the right to router D2. We see the respective subnets there as connected routes. So anytime you look in a switches IP routing table and you see physical interfaces there as the outgoing interface on a route, that's a clue that it's a routed port because you configure IP addresses on the physical interfaces when they are routed ports. All right, study group, where do we go from here? Well, with this topic, it's a great one to practice from the command line. Partly that's because you see things that look like router configuration in a switch. You see show command output that looks like it's from a router in a switch. That takes a little bit of getting used to. You may also see SVI configuration in that same layer 3 switch, or it's a good place to practice that. So it's a great place to explore and pull ideas together. To that end, we've got a config lab on this topic. I've got config lab intro and review videos for that. Here's the direct link to the lab. So as usual, config labs, there's a blog page that explains the lab, but I've got these additional videos to help you get a richer experience. But what you'll do is you'll enable IP routing, you'll enable the routed ports, you'll configure the IP addresses, much like we just saw, and I'll supply in the lab the OSPF config, again, expecting that you haven't gotten to the OSPF topic yet, so I'll supply that for you. Now, as for the books, it's always useful to read the book section as a second source. I do try to give you a little different approach here and there between the videos versus the books, but since we've got a video then that applies routed ports to a layer 3 ether channel as the next teaching video, I would say wait. Wait until you've watched that video, then give it 3 or 4 days, and then go back and read the matching book section for review. Hey, thanks for hanging until the end. As I mentioned, that next teaching video is about routed ports, but in the context of multiple parallel links in an ether channel, a layer 3 ether channel. Click on the left for that video. If you're ready for that lab where you can apply routed port concepts in lab, click on the right for the intro video for that lab. Thanks for hanging out. I'll see you in the next video.